Chuo Kikuu cha Sokoine cha Kilimo Soest.
Hello, welcome to this lecture, Applied Animal Nutrition, with the course code AS201. My name is ELISHA LYAWATWA, Tutorial Assistant in Animal Science at Sokoine University of Agriculture. Today I'm going to cover Module 2, which is Nutrient Analysis of Feedstuffs. And after completing this session, it is my expectation that you will be able to describe various analytical procedures that are being used in determination of nutrient composition of various feeds. So, by starting, you have to know the contents which we are going to cover. So, we are going to cover what is nutrient. You have to know first what is nutrient before going to know the nutrient analysis. And then you have to know the analytical procedures that we are going to discuss today. And these analytical procedures are proximate analysis, Soest, atomic absorption spectroscopy, and near-infrared reflectance spectroscopy. So let's start. What is nutrient? A nutrient is a chemical composition of the feed. Nutrient is a chemical composition of the feed. Nutrient is the chemical composition of the feed, and it has several groups. Some of them are carbohydrates, proteins, lipids, minerals, vitamins, and water. These are the major groups of the nutrients. Now, why do we perform the nutrient analysis of feedstuffs? You have to know the importance of doing the nutrient analysis of feedstuffs. We need to understand first that nutrients or nutritional composition of feeds varies with different factors. And these factors include the location, geographical location of the area, geographical location where the feed has been sourced from, but also the processing techniques, the climatic conditions, the soil fertility, and the maturity stage, as well as species of the specific feed. So all these affect the nutritional composition of the feeds. So for you to know how much of this feed you should add to your feed, or how much of this feed ingredient you should add to your diet, then you have to know the chemical composition or nutritional composition of that feed. Now, after knowing the nutritional composition, now, what will it help you? What will it help you as an livestock manager? What will it help you as a livestock manager? We say it will help you to do the feed formulation. You will be able to do the feed formulation after you have known the right proportion of specific nutrients in a certain feed. Then you'll be able to know how much of this feed should I add to this diet, how much of this should I add to this diet, so as to make a complete diet which will meet the nutritional requirement of your animal. But also it will help you to optimize the nutrient utilization of the feed. After knowing the right proportion of the feed, then you'll be able to know how much of this feed should I provide to my animal. And then after knowing that, you'll be also you will be able to also reduce the feed cost. Now, what are the fractions of the feed? The fraction of the feed, we say feed has two major fractions. The first one is water, and the second one is dry matter. And in the dry matter, there are also two major components, the organic fraction and inorganic fraction. The organic fraction comprises of carbohydrates, comprises of fats, comprises of proteins, and vitamins, while inorganic fraction comprises of mineral. So when we are going to do the nutrient analysis, what we want to determine is these organic and inorganic fractions of the diet. These are our major target in doing the nutrient analysis. Now let's start with proximate analysis. The proximate analysis, this is an analytical procedure which was developed in Germany at Wende Experimental Station in 1865. And this procedure has several components in it, and one of them is dry matter. The second one is crude protein. There is also crude fiber. There is also crude fat, or we call it ether extract. We also have the ash component of it, and then we have the nitrogen-free extract. So the proximate analysis has 6 major components that we are going to cover today, and we are going to start with dry matter. The dry matter, this is the component of proximate analysis which is used in determining the moisture content of the feed. This is a procedure which helps us to determine the moisture content of the feed, and it is much more precise than using the moisture meters. If one is using moisture meter and the one is using the proximate analysis in determining the moisture content of the diet, then proximate analysis is much more efficient than using the moisture meter directly. But this procedure, even though is having the higher precision in determining the moisture content of the diet, it is also associated with some errors, and these errors are volatilization of the of volatile fatty acids, also essential oils, and lactic acid, which are lost during the heating or drying of the sample. When you dry the sample at 105 degrees Celsius for 24 hours, there are loss of some nutrients, and these nutrients, when they are lost, they cause what we call underestimation of the dry matter content. So this is the major error of the dry matter content or dry matter determination. But also we have to look on the crude protein as one of the component of proximate analysis. Crude protein, this is the procedure that helps us to determine the amount of protein present in that feed. And we determine that amount of protein present in the feed principally by looking at the amount of nitrogen that the feed is having. So there's a procedure known as Geldal analysis or Geldal analytical procedure, which enables us to determine the right amount of nitrogen which is present in the feed. And after you have known the right amount of nitrogen present in that feed, you will be able now to multiply that amount with the factors, with constant factor, so as to come up with a right amount of protein present in the feed. So you take the amount of nitrogen in percentage that you have obtained, the amount of nitrogen in either percentage or gram that you have obtained in that feed, and then you multiply that with the factor, which is most of the time 6.25. So after you multiply the factor with the amount of nitrogen present in the feed, you will be able to tell the amount of protein present in that specific feed. So there are possible errors which are being associated with this procedure, and the major one is that Geldal analysis or Geldal analytical procedure assumes that all nitrogens which are obtained during the procedure are coming from the feed, but it is not true. Some of them are coming from urea, some of them are coming from DNA or RNA, which cannot be obtained by the animal. For example, DNA and RNA, it's hard. So determining the crude protein by using Geldal assumes that all nitrogen present in the sample are coming from the feed, which is not true. And also the use of that factor, which is 6.25, it is adequate, but you cannot apply it to all feeds because there are feeds which have different proportion of the nitrogen content. For example, if you go to oil seeds, they have almost 18.5% of the protein. So it is not right to say 6.25 is the global factor which we can use in all the proteins. So that are the errors associated with the Geldal analysis. But there's one thing which you need to understand, that determination of crude protein or the crude protein content is of higher importance in ruminants, but not in non-ruminants. If you have determined the crude protein content of the feed, let's say you have this diet, maybe the diet A, which is having 20% or 30% of crude protein, and you have another diet, which is diet B, having 60% of crude protein. To ruminants, the diet with the higher crude protein is of much more higher values than the diet with less amount of protein. Why? Because ruminants, regardless of the quality of such protein, if you provide that feed to the animal, there are microbes in the rumen that can change the quality of that protein to conform with the requirements of the ruminant. So those microbe in the rumen can change the protein, which is of low quality, to a higher quality protein. We call it microbial protein, which can be utilized by the animal. So to ruminants, the higher the protein content, the higher the quality of the feed. But to non-ruminants, the higher the crude protein is not necessarily the higher the quality of the protein, because to non-ruminants, what they really what they really after too is what we call the amino acids. So it can be the feed having high amount of protein, but the quality of those amino acids present in that protein are not is not good, or the amino acid profile of that protein is not of higher quality. So that will lead to poor performance of the animal. So if you have determined the crude protein content of the diet, once or when you want to provide it to non-ruminants, you have to go further to determine the amino acid profile of that protein, so as to be sure that this diet is having the right amount of essential amino acids which are required by the non-ruminant. Now, there is another component called the ether extract. The ether extract, this is the one which is used in determination of crude fat. So, principally, crude fat is one of organic substances which are soluble in the organic solvents, specifically ether. So, to determine the amount of crude fat in the feed, we use ether. So, if we take ether and dissolve the feed samples in that ether, then it is our assumption that those crude fats will be dissolved in the ether. And if you take the residues out of that ether or out of that solvent, then the crude component, I mean the crude fat component, will have remained in the ether solvent. So this is the principle behind the ether extract procedure. And after you have remained with the residues, then you can tell the amount of fat present in the feed by taking the weight of original sample, you minus by the weight of the dried residues. But this procedure is associated with some errors. And this error is the crude fiber or crude fat, which has been determined by the ether extract procedure. You cannot tell the quality of that fat. You cannot tell the quality of that fat, whether it is either saturated or unsaturated. You cannot say. So that is the major error associated with the ether extract. But also, the ether extract procedure assumes that all substances which are soluble in the ether or in organic solvent are fats. But it is not true. Some of them are resins, some of them are waxes, which can be soluble in ether. And so, after you have gotten the value of ether extract, you will assume that this is just for the crude fat, but it is not true. And this will lead you to the overestimation of the crude fat component of the diet. Now, there is another component of proximate analysis called the ash. And this is the one which is used in determination of the mineral component of the diet. And the principle behind it is that if you burn the feed sample in the Murphy furnace at about 550 degrees Celsius for 4 hours, all the organic samples or all the organic components of the diet will have been burnt. And so we will remain with only the mineral component. So this is the basic principle behind the ash component. But this procedure is associated with an error. And this error is that burning of those samples at a very high temperature, 550 degrees Celsius, is associated with volatilization of some volatile minerals, specifically selenium, iodine, and zinc. Also, chloride is being lost, is being evaporated. So this is the major shortcoming or the major error associated with this procedure. But ash component also cannot tell the right proportion of specific mineral present in that feed. But if you want to determine the amount of minerals present in that feed, specific amount of minerals, then you have to take the feed sample and put it into another procedure. And this procedure is what we call the atomic absorption spectroscopy. So with atomic absorption spectroscopy, you can tell the right amount of calcium, the right amount of phosphorus, the right amount of zinc each mineral can be determined with its proportion to the specific diet. Now the crude fiber. The crude fiber is one of the proximate analysis or the proximate analytical procedure, and this is the one which helps us to determine the insoluble fibers present in the feed. And with this procedure, we say the determined one is the insoluble fraction of the feed, and you have to know two things. The first one is that for non-ruminants, the determination of crude fiber or the crude fiber is of little value energy-wise. The crude fiber is of little value energy-wise when it comes to non-ruminant. Why do we say this? Because non-ruminant cannot extract all the energies bound in the crude fiber, especially in insoluble fibers. But they can extract the energy found in soluble fibers like pectins, alpha glucans. They can extract those energies from those soluble fibers. But in case of insoluble fibers, they cannot extract that fibers because they don't have the features that will help them to digest those insoluble fibers. But for the case of ruminant, this is of higher value. It is of higher value energy-wise because they can extract all the energies, the larger proportion of energies bound in the crude fiber. But you need to understand another thing, that even though the crude fiber is of higher energy, is of higher value energy-wise in ruminant, determination of crude fiber alone, when it comes to ruminant, it is of less importance. Determination of crude fiber alone, when it comes to ruminant, it is of less importance. Why do we say this? Because fibers are not made the same. There are fibers which can be digested, the insoluble fibers which can be digested by the ruminant, but there are other insoluble fibers which cannot be digested by the ruminant. And in the crude fiber, under the umbrella of crude fiber, there are fibers known as hemicellulose, others known as cellulose, and the others known as lignin. Hemicellulose and cellulose can be digested by the ruminants, but lignin cannot be digested by the ruminant. So you can have a diet and you know the amount of crude fiber of that diet, and you see as if it is a reasonable amount which you can just provide it to the ruminant and the ruminant can just strive well. But you will be wrong, because what if those, that amount of fiber, larger proportion of it is made up of lignin, which is not soluble in the ruminant. So for you to be sure of that, you have to go for another procedure known as Van Soest. The Van Soest will tell you the right proportion of these fibers under the umbrella of crude fibers. So Van Soest will tell you the amount of cellulose, it will tell you the amount of hemicellulose, and it will also tell you the amount of lignin. And after you have determined all these fibers, then you will be able to make a decision that should I provide this feed to the animal or not providing this feed to the animal. And the Van Soest has three major components. The first one is called neutral detergent fiber. With the neutral detergent fiber, you can determine the hemicellulose, cellulose, and lignin. You'll be able to extract all the soluble components of the diet and remain with three major fibers in it, which is cellulose, hemicellulose, and lignin. But also, there's another component known as acid detergent fiber. Acid detergent fiber will be able to digest and to extract the hemicellulose and remaining with the cellulose and lignin. With cellulose and lignin. So acid detergent fiber helps you to determine the amount of cellulose and lignin in the diet. And then the last one is called acid detergent lignin as the last component of the Van Soest. With acid detergent lignin, you can be able to digest the cellulose and remain with only lignin as the residues. So with these procedures, then you'll be able to determine the right amount of hemicellulose, the right amount of cellulose, and the right amount of lignin. And you'll be able to make decision on whether you should provide the feed or not provide the feed to the animal. The possible error associated with crude fiber is that the acids and bases which are used alternatively in the process of determining the crude fiber component, they are usually solubilizes some of the true fibers. Those acids and bases solubilizes some of the true fibers, and the result is underestimation of the crude fiber. So this is the error associated with the crude fiber component. Now there's another component of the proximate analysis known as nitrogen-free extract. The nitrogen-free extract, this is determined just by doing the subtraction. You take the dry matter value, and you subtract all the other proximate values which you have obtained. So you take the dry matter, you minus the ether extract, crude protein, ash, and crude fiber, and then you will be able to come up with the nitrogen-free extract. And what actually the nitrogen-free extract is? The nitrogen-free extract represents the soluble carbohydrates of the diet. So after you have the dry matter, in order for you to determine the proportion of the soluble carbohydrates, you have to do the subtraction, because there is no analytical procedure which is directly responsible for determination of the soluble component of the diet. So for us to determine the soluble component of the diet, I mean the soluble carbohydrate of the diet, then you have to do the subtraction of other proximate components from the total dry matter of the diet. Now there's the last procedure known as near-infrared reflectance spectroscopy. Near-infrared reflectance spectroscopy, this is the modern procedure which is used in the nutrient analysis. And with this procedure, you can do the simultaneous analysis. You can do the simultaneous prediction of multiple nutritional parameters. With this procedure, you can do the proximate analysis. With this procedure, you can do the Van Soest. With this procedure, you can do the digestibility indices in the same time. And it takes a very short time, because it just uses the infrared with different wavelengths, determining the different proportions of nutrients present in that feed. So this is to mark the end of the session, and I welcome you to the next sessions. Thank you.
Chuo Kikuu cha Sokoine cha Kilimo SUA.